want you to look at the periodic table for all the known elements in here. And you want to find an element of the periodic table with your first initial. We're going to ask you to change your participant name into that element. For instance, my first name begins with the letter A. So I change my name to aluminum. And I'm just going to start reading some of these off. My friend nitrogen is being used for chip bags, preventing oxidation and keeping them fresh. Sulfur smells like rotten eggs. Very true. I have a melted point of 2,000 degrees C, and I'm not one to crack easily. That is some good descriptive writing. So you tell me, what are the three differences here?
I know atom and compound. So atom is like one singular atom like iodine or helium, and it's only one. And a compound is basically made of at least two or more different types of elements from the periodic table.
Anybody got a definition for a molecule?
Molecule is when there are two or more of the same element joined together, basically. And compound is when they're different.
Very good. So when they're compound, they're different. It's like a combination. All right, we got carbon. There's a lot going on. All right, hydrogen. Boom. There we go. Positive, proton, electron. Boom, boom. Neurons. Nothing. Oxygen. Boom, boom, boom. There we go. All right. Neon, we're working on it. Okay. And oxygen.
So you'll have to research about the risks, benefits, and the common uses and the regulations about carbon-14. I think 14 is the isotope.
So, is there anyone that wants to do what are the risks associated with the element?
Somebody from group 2, the carbon crew. Let's hear a risk.
Carbon-14 is the only radioactive carbon, unlike carbon-12 and carbon-13, and it's a beta emitter. That means it emits low energy beta particles that cannot penetrate skin deeply, but can really damage tissues if it inhales or get in the body from outside.
Group 3, can you share one of your benefits of iodine, please?
One of the medical benefits to I-131 is after surgery to remove thyroid cancer. So it's often given to eliminate any remaining thyroid cells or cancerous tissue left in the body after the surgery.
Uranium. What's the common uses of uranium?
So some common uses of uranium, they are used in weapons, military armor, because it's a very, very strong metal. And they're also used to determine the age of rocks and fossils using uranium.
Not only do we have elements in a periodic table, we have alloys, which are a combination of two or more metallic elements. And what these things do is they give them greater strength, resilience to corrosion. These are the kinds of materials we'll be using in our spacecrafts, most likely.
So do we want to discuss it all together?
Yeah, sure.
So we're supposed to find an alloy name. We need to get the key properties and we need to see what's in the alloy.
Steel's made out of the main element. There's iron and carbon, it says. And then there's other steel, like stainless steel and stuff that would probably have different. It says carbon is in small amounts, usually less than 2%.
Why would a steel alloy be good for space use?
So metals that tend to stay in shape after being melted together unless, exposed a very high amount of temperature. Like in the steel, it melts at only 1400 to 1450 degrees Celsius, and also the same with like negative cold temperatures. It's really resistant to high temperatures and low temperatures.
Okay. So it's got that good temperature resistance in there and holds shape. Let's think about another reason, like, why would we use steel alloy versus, like, say, titanium?
It's actually cheaper and easier to work with than titanium.
Which is steel? Yeah, that's the kind of angle I was actually hoping you guys would go at, like practicality. Like, titanium is super expensive.